Good morning. Monday, 7th of December. The sun is just barely starting to rise in Berlin, and here we are for day 7 of the Advent of Code. It's been pretty easy so far. I think today is starting to look a little bit more like a challenge. Already had a look at the puzzle, but I think it won't be too bad if you kind of look at it the right way. Um, this time I put a big post-it note on my screen to remember to switch. Hey Vincent, good to see you here every morning. Very cool. And here's Vincent again on our leaderboard. So I set up a leaderboard for all the Lambda Island folks, everyone following the streams and the videos, everyone who has a Lambda Island Code account. You can find the code of this board on lambdaisland.com/news. It went out in a newsletter, but if you didn't have an account yet and you didn't get that, you can still find it there, lambdaisland.com/news. I also shared it in the Lambda Island channel on Clojurians. So some familiar names here, very cool. Yeah, Vincent is clearly going competitive this year. I don't. I mean, as you see today, you know, I was actually awake at 6 when the puzzles go live. It's 8 now. I'm not gonna rush this stuff. I had my breakfast. I read the puzzle already. Had a think over. Yeah, so Vincent, as I think, is still in Taiwan. So it's afternoon there, I guess now. So that makes it a little easier. Hey Maria, cool to see you on the leaderboard. Here's Alice, who's been working really hard on some Kacha open source issues, so that's cool. Nice to see Joshua here, even though it seems like he hasn't been trying too hard yet. But maybe he'll catch up, you know? Might not make it high in the ranking, but might still get his stars. So thank you all for being here, participating, talking on the live stream, leaving comments on the videos. Really appreciate it. Speaking of comments, we got a bunch of comments yesterday. Torsten said, thanks for the daily session, Arna. I enjoyed it very much. The best part is guessing at one point in the beginning of your stream, you will switch to your editor view. So this time I remembered. Although I feel like I could just start making it a running joke. Günther asked, good morning, thanks for the great series. Which Emacs package do you use for navigation, copy, paste, and editing the as expressions? That's kind of a big question. I can tell you a little bit about my Emacs setup, but really I'm going to have to do some separate videos if you folks really want to know more about that. Yeah, the review of the other common solutions is quite helpful. Thanks. Not going to do too much of that today, although I do want to revisit briefly my solution from yesterday. Calva TV, our Calva friends, said a reason to use the sample input is to quicker get feedback on them tiny mistakes. So yesterday I jumped straight to the proper input and I got it wrong the first time. And yes, that is my hubris getting the better of me. Larry Wall, the creator of Perl, I believe did say that laziness and hubris are some of the virtues of programmers, but it can come back to bite you. Pranav says, wow, thanks for reviewing my code. Of course, super helpful that folks send in their code and we can look at that, see how different people approach it, kind of share some Clojure tips. Yeah, if you want me to show your code on the stream, link it. Don't paste it in line, but just link to it in the comments, and I'll see if I can get to it. And then Alexander said, like your solution for the part 1, it also could be done like this, reduce plot mat. And then he's using a disjoin to get rid of those new lines. Yeah, that's the part that I wanted to briefly look at again. So yeah, thanks for the folks on the leaderboard. Some things I already learned. I mean, there's always more to learn. I didn't know about string split lines. I didn't know about string escape. Haven't showed string escape on the stream yet. But it, as I understand it, basically lets you take a string and you give it a map. and then it's going to replace instances of those characters. Let's see if that works. We have all this interactive environments. Might as well make sure we're not telling folks nonsense. That's not an import, that's a require. Are there any folks on the stream already besides Vincent? 2 concurrent viewers. Do say hi, second person. Yeah, so that does that. So that's cool. As I mentioned, didn't really know about take last. And then, not on yesterday's video, but on an earlier video, Tomias Adams said, cool series, always interesting for me to learn by watching how other people work. The iterate function was new to me, and the strings destructuring. Yeah, so this is one of those things that not that many people know about because you don't use it that much. But if you have a function, you know, like everyone knows about the keys destructuring. But if those are not keywords in your map, if those are strings, string keys, you can destructure with strings. Less well known, but it's already come in handy on one of our puzzles. Also, the little trick of using thread last threading within thread first threading is neat. Thanks for sharing, and I'll tell you guys a little trick, a little rule of thumb. Basically, if your outer thread macro is oh, there's even sims. Vincent tells us, and I didn't even know that. You can use sims. Foo 1 2 3 bar 4 5 6. Foo bar. Yeah, sims. So we have sims, keys, and strings. And then I'm guessing here you can also do the namespace thing. All right. Yeah. So this is kind of so when you're dealing with namespaced keywords or symbols, I see people do this, which I actually don't like. I think it's kind of weird to have those keywords in there, but I might do that, and I see that a lot too. But if you're destructuring a bunch of symbols or keywords with the same namespace, then just stick the namespace in front of sims or keys. I don't think that does anything for strings because those don't really have namespaces. But yeah, as I was saying, basically, if your outer threading macro is any kind of thread first, so a regular thread first, or a cond, or a sum, then you can nest any other threading macro in here. And that makes sense, right? Because like all these threading macros take as a first argument the thing that you're threading. Why is it giving me warnings even though, what does it not like? Oh, I turned on boxed math warnings somehow. That was not really intentional. Yeah, so a little trick, little rule of thumb, and I mean, you know, like nest threading macros sparingly. You don't want to get too crazy with this stuff. But sometimes it's pretty neat actually if you have, you know, like say a regular threading macro, and then you want to either, you know, like stick a cond in there because you want to do some stuff conditionally, but not all of it. Or you want to stick a sum in there because you might have some nils that come back. Or, you know, you start, for instance, with an object, do some operations in there, and then at a certain point, you get a collection back, and you want to switch to doing sequence processing, you know, then you can kind of end with a thread last where you do that. So stuff like that, I think, is okay. You know, like, of course, you don't want to overdo this, but sometimes that's actually totally okay. All right, yeah, like I said, I wanted to briefly still revisit my yesterday's solution. So I did this all with set operations. But in hindsight, I'm really just using these sets to get, you know, the distinct items in a collection, right? So I think what we can also do, actually distinct does not have a transducer version, right? Or does it? I think maybe it does. So that means that I think we can actually also write this as transduce and then remove, and then I'm just going to use a set as a predicate to remove the new lines. Yeah, and then, yeah, I guess maybe start with a map cat because we got these groups. Does that work? What do we get here? Map cat identity. Oh, I guess I just want a cat actually. Oh, transduce. Yeah, that's. Well, let's start with a sequence because I don't want to. Right. So now we have the distinct things, and I can count those. 26. I no longer remember exactly what the. Oh, you want to? Okay, yeah. So no, I don't want to cat them. I want to map over each group, remove the no line, get the distincts, get the count, and then sum them together, and then I can use a transduce. Current filter gonna because it calls a number. Wait, am I doing this right? I am not doing this right. Transduce X form F collection. So this is going to get a single group. It's going to remove the new line. Okay, let's start with an identity. What is do I want to? No, actually, I think I want comp plus count. Does that work? Oh man, wrong number. Why is it? Oh, cause okay, yeah, this is transduce, right? Like it really wants. Okay, if I give it an initial argument, that might be better. Yeah, you do think it should be map? Yeah, so this is the annoying thing with transduce, right? That it expects to have a 0, 1, and 2 argument version of this reducing function. Okay, do I want to spend more time on this, or do I want to get to the next exercise? I feel like I do want to get this, but I'm just going to do it step by step, make sure that I get this. So basically what I'm trying to do is, let's first do it as like just regular sequence operators. So I have my groups. I'm going to map over the groups. And so for each individual group, I first want to remove the new lines. Let's actually, no, I guess, yeah, let's do it this way. Yeah. Now, can I do this with a... So yeah, I'm kind of nesting transducers. That's kind of... Yeah, so the comp order changes if it's in a transducer or not, right? So I got my groups. It's still early. Okay. I removed the new line. So yes, comp. So first remove the new line, then get distinct, then get count. No. Jesus fucking Christ. What? Oh, because I did this. Okay, so then get distinct, then get count, right, and then add those together. Yeah, so that's really all I wanted to show, that like, you know, I'm using these sets here, but I really just could do this with sequence operators too, and using distinct. All right, because we're already 15 minutes in, let's get to today's exercise or today's puzzle. Yeah, so I had a look already at today's exercise. So handy Haversacks, day 7. So the story continues. We land at the regional airport in time for your next flight. So remember, we're on our way to a tropical destination, but we have a stopover. Yeah, we have some time to grab some food because all flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules are being enforced about bags and their contents, and so the puzzle input is these rules. Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently, nobody responsible for these regulations considered how long they would take to enforce. For example, consider the following rules. Light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 3 bright white bags, 4 muted yellow bags, and so forth. So these rules specify that given a certain color of bag, it has to contain a certain amount of other bags with certain colors or coated with a certain color. So in this case, every faded blue bag is empty, but a vibrant plum bag contains 5 faded blue bags and 6 dotted black bags, so at least 11 bags. At least, no, I guess exactly. Contains specific quantities. Yeah. Now for the first exercise, it seems like we don't really need the quantities yet. It just says, okay, we have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag, considering that we can put, you know, one bag in another bag in another bag. So in this case, a bright white bag can contain a shiny gold bag. A muted yellow bag can also contain a shiny gold bag. And so that means that we can have a bright white or a muted yellow bag, and then those again can go into other bags, for instance, in a light red or a dark orange, because both of these take either white bags or muted yellow bags. So that means that our shiny gold bag can go into 4 different kind of bags. So my first reaction was like, okay, right, now it's like, now they're throwing the hard stuff at us. But what I'm feeling with this advent of code stuff is that really my impression of how they come up with these exercises is that they just sort of take, you know, common computer science problems, common algorithms, common data structures, and then sort of come up with a description of an exercise that maps exactly to that thing, but obscures it, right? It's like, and if you see it, you know, like remember a couple days ago, it's like, okay, all they really asked us was to decode a binary number, but they really went out of their way to make it not look like a binary number. Although there was a hint that they called it, binary something something encoding. So in this case, I think what we're really looking at is a transitive graph search, right? So this is actually extremely similar to, for instance, dependency graphs, right? So you can say like, okay, the light red library has a dependency on the bright white library and the muted yellow library. So given light red, which libraries need to be included, given that these have their own dependencies. Although in this case it's actually the other way around, right? So I think we want to model our graph with the edges going in the other direction. So we can say like shiny gold has a dependency on dark olive and vibrant. No, the other way. Shiny gold has a dependency on bright white and mutant yellow, and then and so forth. Now I considered doing this either with a graph library like Loom. There's also Stuart Sierra dependency, which was extracted from Clojure Tools namespace, where it's used to compute the dependency graphs of namespaces. So this does that. This allows you to do a transitive get transitive dependency. So then we sort of have it in a library. Now that does not allow us to model these numbers, which you can think of as weights. Like in graph theory, you could have weights on your edges, and that's really what we're talking about. Now Loom is a Clojure graph library, which does have support for weighted graphs. And then a third option that I considered was Asami, which is an in-memory graph database with a data log interface developed by Paula Guerin for Cisco. Well, she started on it on her own, I think, and then Cisco was like, hey, this is a really cool thing you're working on. And so now she's being paid to continue to improve this. Super cool library. She's working on adding persistent storage. So far, it's still an in-memory graph store. And I think it might be fine to try, or might be fun to try to use these things. But I think I'm first still just going to try to do it with vanilla Clojure. And see how far we get with that. I think we can just, use a map and then see how far we get with that. So I'm not gonna make the mistake I made yesterday. I'm gonna start with the demo input so we can verify what we have. Puzzle input 07. And I guess I'm putting this in a file because I feel it's already a little big to stick into the namespace, but I'm gonna put a couple here just to kind of see what we have, and then demo puzzle 07. Yeah, hold on, this is the demo input. Let me also already fetch input 7. So the real input is this guy. All right. And here in the examples, we only ever had at most 2 of these dependencies, so to say. But here it seems like you can have an arbitrary amount, so gonna split those. Just gonna do some regular expression bashing on that. So it seems like Gonna start with the. Actually, I'm gonna start with splitting this on either the word contain or a comma. Yeah, fighter pullbacks. So then we have sort of, you know, the starting point and the dependencies, or the reverse dependencies. And let's maybe say that this can contain some white space at the front and at the back so that we lose that. How does that look? Yeah, second one still. Yeah. And then I don't have good names for these things. What do we call this? Bag and dependencies? So and these are just two words. It's always two words that it starts with, right? Shiny indigo, clear lime, dotted turquoise, bright red, vibrant magenta. Yes, just gonna take two words. And then yeah, if we have this one, good. So then we can do an RE find on bag, basically saying not quite what I was expecting. Well, let's just do it this way. Word plus. Yeah. Oh, and then I guess if we don't do this, then we just get that. That's exactly what we wanted. And then for each of these color dependencies, we say refind. Well, and then, well, for here, yeah, let's, we have two options, right? Well, actually, no, let's just say refind, and then if it's no other bags, it's just not gonna match, we get nil back. And I think that is okay. So D plus probably could be more than 10. And then a space, and then the same thing. A bunch of word characters and some more word characters. No, we're not passing our string to refind. Let's just partial this. 5 faded blue, 6 dotted black. Okay, I'm gonna pull some stuff into functions. Or just make this, I guess I'll just make this a single function. Okay, if I comp this with a next, what happens if there is nothing? So, okay, we're gonna have bag, Haversacks nil. Is that what we want? Maybe. Okay, defn parse entry. Use keep. Good tip. So yeah, that means that we'll get an empty seek in this case, which we can then check with seek. Okay, so let's see if we, let's not get too crazy. What am I doing? Okay, map parse entry demo input. Yeah, that looks okay, huh? And now, like I said, at the first pass, we're just gonna ignore the numbers. Just gonna call this color graph given these entries. And we're gonna build up a map. Let's see, no, let's maybe reduce this. Entries, and then so we get the map and we get an empty, which is the bag and the depths. And then we reduce again these depths, still passing through this map. And we can destructure this. This is the num and the color of the other bag. And in this case, we want to, actually, no, I don't want to assoc. I want to update this map for this given color, and then just conch bag. Let's see, that's already a little bit of an ugly function, but I think this, well, let's see if it works. Color graph. Yeah. And so let's see. So we have our shiny gold bag, which, oh, it still has the bags on it. How did that happen? Oh, it's this one which still has the color bag string split. Oh, okay, yeah, I'm using the wrong one here. It's color, it's not bag. Yeah, that looks better. And now it's just a matter of defn, what do they call it here? Fine, you have would be valid for the outermost bag. So let's say valid outermost graph start. And just, yeah, so let's say we get I'm gonna loop result, say that's an empty set, and then let next result into result get graph color, this, right? I'm gonna add a helper, add valid result, which is just gonna be into result. Yeah, so get graph color. And now we kind of recursively say, let's try this again. So we start with result and color. No, I'm making this, I'm overthinking it. I just need to loop over the result that we have. So let's start with actually add valid graph start. And then let result2 reduce the current result that we have and add those to the result in the sense that, so this is my accumulator or my result, this is a color, yeah, and then we add valid to the result given our graph for this color, and then if result is result2, if it no longer expands, then we're done. Otherwise, we recur with result2. Does that seem reasonable? Given a graph and shiny gold. Yeah, that returns 4 entries, and then we need to count those. Okay, now for the real input, I'm still looking at a shiny gold bag, right? So let's say if we take the real input, and now, yeah, that's still fast enough. 3, 3, 2, 2, 2. All right, so far so good. Now I am curious though, because now we're probably going to need these numbers. Okay, it's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Faded blue, yeah, okay, yeah, so those are just the same rules again. Are they? Or they're a subset of those rules? So a single shiny gold bag must contain 1 dark olive bag. Oh, I think now we're going in the other direction, right? So a shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags, and the 11 bags within each of those is 32 bags. Of course, the actual rule have a small chance of going several levels deeper than this example. Be sure to count all of the bags, even if the nesting becomes topologically impractical. Here's another example. Yeah, so now we, starting from our shiny gold bag, now we're going in the other direction. Need to find the total amount of bags, and in this case, we just need to keep expanding it. And yeah, so the ones with 0 bags are gonna be the leaves. So yeah, we're just gonna have this tree structure in a sense where it terminates with the ones that don't contain anything else, but everything else we need to expand. Okay, so I guess given the first rules, we should get to 32. Then we can try this other example. Okay, how much of what we have can we reuse? I guess parse entry is still good, but then yeah, we're gonna just duplicate and adapt nesting graph. So in this case, we reduce over the entries. We have a bag and its dependencies. We get the number and the call. And in this case, we need to go in the other direction. So given a bag, const num-call, how about this? And I guess maybe here do some long parse long. Yeah, I think we can really just write a recursive function over this, huh? And we only need to count. So color count given a graph and a color. Get graph color, and then reduce color. So here num color is one of these, right? And then we say plus the count that we have so far, multiply num with color count of the graph and this new color. I don't know if folks find this confusing that I'm shadowing this this variable here. Not too confusing to me right now, but maybe if I read it tomorrow, I'll think differently about that. Oh, and we're getting a boxed math warning, which if it turns out that this is too slow, that might be a first good candidate to look at. Also, this might be a good candidate for memoizing. But let's see. So color count, let's say def graph shiny gold 0. Fantastic. Oh, wait a second. The bags themselves, like we're counting. How about this? So do you see my mistake? Like I'm multiplying with you know the number I'm getting further down the graph, but nowhere do I actually count an individual bag so that I can multiply that. So we're just multiplying 0 with 0 with 0. Okay, that's a little more than I expected. Supposed to get to, am I misunderstanding the question? 1 plus 1 times 7 plus 2 plus 2 times 11. Or are these different rules? But like it must get down. They're not saying anything about shiny gold bags here. Oh, this is a different example, because here they're saying a shiny gold bag must contain 1 dark olive bag and 2 vibrant plum bags. But here I'm getting dotted maroon, vibrant indigo, shiny gold. Oh no, am I parsing this? Am I using... Oh, I'm using the real input already. That's why. Okay. 8. That is then a little less than we're expecting. Yeah. 2 vibrant plum, 1 dark olive. And then dark olive, 4 dull black, 3 faded blue. I mean, this clearly has to be... but we have an... what's... Oh, yes. Okay, yes. I see what's happening. Let... entries. We need to bottom out here. If seek entries, then it's all this with the entries. If not, then it's 1. 37, 32. But now maybe this is not strictly correct. No, 29. Okay, I'm just throwing stuff at the wall now. Let's put some prints in here to just kind of see what it's doing. Okay, so if we compute the color count for a shiny gold bag, then it correctly bottoms out at dotted black. So shiny contains 1 dark olive bag and the 7 bags within it. The 7 bags. Oh, there's also other bags. Is that right? Dark olive. I don't know, it's just, okay. Yeah, so 4 dotted black, 3 faded blue. So, and dotted black, so yeah, dotted black, that's a single bag. Plus 2. So dotted black, that just counts as 1. Same for faded blue. Now with vibrant plum, six dotted black, 5 faded blue, does each bottom out, so those are 11 bags, so that is right. Dark olive, that's also correct, which means that our shiny gold contains 2 times 11, 1 times 7, yeah, plus the bags themselves, right? So this, each bag counts as 1. It has to be like this. But we're getting too much. Because now Vibrant Plum contains 13. No, okay, yeah, no, that's not right. No, at 13 that is right, because we have 11. 2 times 11 plus 2. No, I think it's either or, right? So this is pretty close, but what are we doing wrong? Dot black, faded blue, or one vibrant plum. One vibrant plum. Should be 12 and not 13, right? Because it's like the 11 bags inside plus the vibrant plum itself. So it's counting. Wait a second. Reduce entries. Yeah, okay, and I'm counting one extra for each entries where I just need to count one extra. So this is a 1. Is that right? Almost. Yeah, so the +1 is wrong, right? Because that's like counting for each entry. Yeah, so this is closer, but we're getting 33, and we should be getting 32. Because it's counting the shiny gold back on the outside, I guess. Right? Like now we're always counting like 1 for each bag, but it's asking how many bags are within that bag. Shiny gold bag must contain. So in total we have 33 bags, but inside are 32 bags. Let's try this. I think we're closer. Puzzle input demo 2. So demo input 2, puzzle input demo 2. Demo input 2. And starting from a shiny gold bag again, 126. Okay, so I think my logic is right now. Now let's see if this runs in a reasonable amount of time. Real input, 10,875. 10,875. All right, cool. Yeah, there was already a little bit of poking around, a lot of reducing. I don't know if there's, I mean, to me, it's like reduce is only one step closer to just doing like sort of bailing out and doing a loop recur, right? It's like, okay, first you try to do it with map and filter and maybe iterate, you know, these kind of nice functional sequence operations. And then if that doesn't cut it, you can go to a reduce and you already have like a lot more freedom. And then if that doesn't cut it, you go to a loop recur and you're basically like almost writing imperative code. Yeah, let's get rid of this debug calls again. Put that in there for reference. What did Vincent say? Map reduce, then transduce. Yeah. Yeah, fair enough. But the transduce, because yeah, it's kind of annoying, right? That like transduce the function, the second argument to transduce has to be a reducing function, which like plus in the sense that it has a 0 arity version, a 1 arity version, and a 2 arity version, and that's not always the case, right? Like and okay, there's like there's a couple of helpers. You can sort of decorate a function to give it an initial value. You can put an initial value in the transduce and then add a completing function with a helper, which I've now forgotten, but sometimes that's a little annoying. Yeah, before I sign off, let's, because I haven't really touched on that yet, so complement, that's the one I was looking for. No, wait, complement. Complement is the one that reverses the bool. No. Complement. Yeah, complement, yeah, reverses it, yeah. No, so complement is the one that changes a predicate to its opposite. Completing, is it completing? Completing, that's the one. Yeah, so you can do something like this. And now it works like a regular conch. But it also has a one arity version. What I've also seen people do, you know, if you have a transducer, so the signature of a transducer is like this, right? And so a transducing contact like transduce is gonna put something in here that you know builds up the collection or whatever. What I've seen people do is just call that directly, and then I guess call reduce with that. So I don't know, that I don't like that much. I find that's a little bit obscuring things or making use of more implementation details of the transducers, but it kind of sidesteps that arity problem. But yeah, like we said, with completing and with the 4 arity version of transduce, you can sidestep that as well. Yeah, so someone asked, and I still wanted to touch upon that, about my Emacs setup. Basically, it's just Emacs and Evil. So, I mean, I got a couple things here. I'm using the straight package manager, just setting some defaults. But for the rest, it's Evil. So Vim style, and then Evil collection adds a bunch more. So Evil kind of provides the base Vim editing. Evil collection adds Vim style commands to a lot of other modes that are built into Emacs, or also a lot of contrit packages. So you know, even stuff like Cider, there'll be like an Evil collection Cider, which then does some stuff on top of Cider. Even though I'm trying to, I undo some of that because it gets in my way. But I don't, things like, you know, direct mode. You know, if you just open a directory in Emacs, make this work a little bit nicer with Vim binding, stuff like that. That's all in part of Evil collection. And then Evil surround is a port of Vim surround. So what does all of that mean? And then yeah, I add 2 more Vim text objects, L and H. L, capital L being next as expression, and capital H being one as expression back. I think in stock Vim or in stock Evil, these go to the beginning and the end of the buffer, or up, yeah, something like that, which I don't really use that much. So I did not come up with those bindings. So yeah, and then it's all just Vim stuff, right? So like if I want to delete one as expression, it's D capital L. If I want to delete 2 of them, it's D2 capital L. If I want to copy 2 of them, it's 2YL or Y2L, I guess. And then, yeah, P or capital P to paste those. And then the Vim surround stuff lets you do stuff like, you know, DI and then parentheses. Now I've deleted everything inside the parentheses that I'm in. and you can give it a specific type of parentheses. So I can also say CS change surrounding parentheses to square ones. So this is all evil surround or vim surround stuff. And then, yeah, of course, there's like, if you want to just sort of do traditional, you know, selection based stuff, then you go either into visual mode with V or in visual line mode with capital V, and then you select something, Y copies it, P pastes it. So yeah, it's mostly just standard Vim stuff. For navigating, I mean, I have comma, so comma is kind of a leader key, which has a couple things under it. You see there G, go places, and then G again, go to definition, so comma GG, and then comma GB to go back. So I use that a lot, like for instance, you know, great if you want to just kind of see how certain things are implemented, check out libraries, use that all the time, and then bounce back. Space JI is bound to console I menu, so this kind of gives you, and it works in a lot of modes, sort of all the different vars that are defined in this namespace, so you can go over those, and it has a fuzzy search on those. So sometimes I'll do that. I think you've seen me do that in a previous episode where I went to Clojure Code, Clojure Core, space JI, and then I can sort of do a fuzzy search on everything that's in Clojure Core, which can be quite useful. So yeah, that's mostly it. It's mostly standard evil / Vim stuff. You've also seen me use this ext prompt. So if you press colon, you get this thing. I mean, this is you get this in Vim. It actually originates from the X editor, which is a predecessor, like a line-based editor, predecessor of Vim. It's also very similar to the kind of editing you get in ed. And then, of course, there's a streaming version of ed, which is sed. So you probably are familiar with sed. So you can do stuff, you know, like this. And it's kind of cool that it shows you what it's going to do. So it's especially because Emacs rejects are a bit weird. Like, you know, if you want to use capturing groups, you need to escape them. So you can sort of experiment and see what it's going to do. So I think that's the main stuff about my setup. All right, longer video today, but we had a lot of stuff to talk about. I thought it was a cool exercise, not too hard yet, but already a little bit more challenging. So really curious how other people solve it. Do leave your comments, share your code, and maybe we'll look at it tomorrow. All right, thanks a lot. See you soon.